Thanks. As Sarah mentioned, I'm going to speak on artificial intelligence, machine learning, and scholarly data, and really empowering and enabling science in the 21st century. Since there are many publishers here, I just want to clarify that I am talking about AI and machine learning in research, not ChatGPT and how to do reviewing and authoring. And there's ethics and other issues around that as well. That's a little bit separate. But this is really on enabling science. And part of this is I've been involved while I was still at AGU, a variety of reports on enabling science in the 21st century to funding agencies. Most recently, a report on actually ethics and code of conducts around AI and machine learning that was sponsored by NASA. And some of what I'm talking about will be out in a couple of weeks in a paper by several of the authors on that report in Nature. So you can look for that as well. It's often you don't recognize it when you're in the middle of it, but we're actually in a revolution in how science is done. Some, not me, have called this a fifth paradigm in how science is done. And, for a long time, Galileo, Newton, and onward, there were some fairly standard ways of doing science. And then about 80 years ago, computational science emerged. And grew rapidly as an additional way of really doing physical models and simulations. And that and technological revolutions have actually led or enabled data-intensive scientific discovery. So that right now we are collecting about our planet, every day information on all aspects of our planet, its space environment, all of its ecosystems, all of society, a massive amount of data. And what's emerged recently is a combination of that and new computational techniques to really understand that, because the data are so big and there's so much power on mixing data sets that in enabling new science that we need AI and machine learning and other statistical approaches to do this. And obviously these overlap, but this new science is growing incredibly fast and it's changing how science is done. Because it requires diverse teams, it's changing how science relates to society, and it should change, as I'll talk about, how we treat our data and reward systems and the whole infrastructure of science. So if you don't believe me, here's some data from the American Geophysical Union. These are the AGU meeting. This is from abstracts in the AGU fall meeting. It's one of the largest scientific conferences in the world. 20 to 25,000 abstracts. And this is in growth of those abstracts using machine learning or AI for results. And as you can see, it's grown from much less than 1% to over 6% of Earth and space science is now based on machine learning and AI on large data sets. And it's across all disciplines. And this is really representative of many other disciplines as well. What's also true is all of this science is incredibly important to society and will be used by society and needs to be trusted by society. And we need to have high integrity in the results, both for those uses and so society trusts science and supports science. So it's a great circle of integrity. So all of the major sustainability issues depend on this data, this huge amount of data that we're collecting and interpreting it and applying it at all scales, globally and even down to building resilience in communities or addressing public health issues. And all of this science is convergent, highly transdisciplinary, and needs to be understood to the extent possible, appreciated, and even used by society and communities. That means it needs to be open and transparent and well described. And that's part of how science is going to must evolve in the 21st century. So all require massive data and integration with modeling, and quality open science with integrity is a must. We must build trust. There's a great danger in this science of garbage in, garbage out. The garbage starts with the data. We need high quality, well-described data so we can mix data sets so that results are understood, so uncertainties are understood, biases are understood, and errors are understood. So enabling quality science in the 21st century involves open and transparent everything. The data must be fair. And here, the key part of fair is interoperable. Obviously, findable accessible is important, but interoperability is where quality comes in and the garbage goes out. Jenny already mentioned CARE, and I will extend this to leading practices in community science. Again, something that the scientific community is not very good at, and that needs to be taught and emphasized better. And then there's new ethics in code and conduct. We like to think about, science, there's this quote unquote reproducibility crisis in science and so on. But actually, AI and machine learning is not reproducible. Are always reproducible. So we need to think about some new ethics and code of conduct around science to avoid biases or mitigate biases in input data, and to make the science as testable and valuable as possible. And we need a reward system that reinforces all of the above. And all of those are necessary for public trust in science, public use of that science, and solving all these enormous challenges that we have. The problem is that, so let me just say, okay, so I was just involved in this. So one aspect is this ethics and responsible use of AI and machine learning. This is an extensive report that was supported by NASA that, although it was focused on the earth and environmental sciences, it really applies, many of these things apply across all of the sciences. We have 4 principles for, it's modular so that it can be introduced into training and education. There's principles for researchers in approaching machine learning and artificial intelligence, as well as for scholarly organizations, including publishers, on how you might check or expect or write author instructions for expanded methods sections and so forth. As I mentioned, some more discussion of this will be out in a couple weeks. But there's the, I think the slides are available. There's the DUI. It's now published as a preprint, and you can also search for it. So, as I mentioned, the key for this starts with interoperable data. And so by interoperable data, that means standard metadata. Interoperable data requires standard metadata for each data set, information on provenance so that a machine or people can understand it, standardization and processing information, information on uncertainties. And the challenge is that interoperable data is very field discipline and data type specific. So that could include issues on processing, compression, data products, annotation, etc. And so one has to essentially develop leading practices across the sciences for the specific data types that those disciplines are producing. And that's obviously challenging going forward as new data sets emerge. The challenge is that we're not practicing fair data now. We essentially mostly have FAW data. And even the new mandates, while they're recommending often curated repositories like Dryad and disciplinary repositories, they're also recommending those repositories that offer no curation at all. And really the interoperability, the key to interoperability is curation of data sets. So right now, the fair data efforts relies on publishers to enforce it at publications. That greatly incentivizes authors to use free general repositories, and I'll show some data on this. The current repository landscape is mind-boggling to researchers. There's about 3,000 repositories, many which have secret restrictions, not so secret or whatever, hard to find restrictions on whether an author can use them or not. That also drives researchers to the simple, easy, free solutions. The funders are requiring fair data, but they are not supporting the repository network to enable interoperability. Institutions, I really appreciated what Jenny says. One message from this is do what Jenny did at UW. Institutions are starting their own general repositories without curations, and they're mostly not funding curation. So as a result of that, basically what we've done is moved supplemental material files from publishers to general repositories like Zenodo and Figshare. Few societies are developing curation standards. They're not supported to do so. We need to fund them to do so. And curation is not supported in most cases. And what's worse is even the disciplinary repositories that we do have, most do not have the staff or capacity to enable the existing mandates. So there's a great danger in creating what I call a FAW data culture without interoperability. So here's some paper. We actually implemented at the American Geophysical Union 3 years ago a mandate for using repositories, strongly recommending disciplinary repositories. But because this was implemented at publications, the authors run to Zenodo and Figshare in particular, because it's easy, free. They get their DOI, they get their landing page, and they go, ha, my data is cited, and I can put a reference in it. Yes, that's great. That's an important step, but we actually need to use the repositories that provide curation. Okay, so 4 challenges for realizing this future. For enabling science and benefiting humanity. And the great thing is actually we know how to do this, except that it's hard. But I'm excited by the energy around this. So one is, and this is already happening, and Jenny mentioned some of this, is work together to really empower the open science ecosystem. This is, I'm not going to explain the diagram at the left, except to say that through PIDs, everything can be linked and identified. And the key is for publishers out there, use data citations, follow the leading practices on how to mark up them, encourage ORCID and credit, and then we'll complete the open science ecosystem. So this is enabled. We just have to do it. Publishers signed up for Force 11 data citation principles, I believe, almost 10 years ago. Please do what you signed up for 10 years ago. Elevate importance of data software and grants. Funders are starting to do this, but still, if you submit a grant to NSF or NIH, the data management plan is the last thing you will fill out rather than the first. There's still great emphasis on intellectual merit rather than something like an outcomes and impact statement that explains how the research will have scientific and societal value and how things will be shared. This is changing. The key is that researchers need to have early contact with repositories, whether Dryad or a disciplinary repository. Curation takes time. It takes several weeks, sometimes longer. Early contact is key. That can be enforced in data management plans. We need to work together, and Jenny mentioned some of this, to really support the research repository infrastructure. There's a big danger I mentioned that general and institutional repositories become this huge dumping ground. As Jenny mentioned, this actually saves money for institutions to actually partner with repositories that are doing things correctly, that provide curation. It's a win-win for the repositories. It's a win-win for the universities. We need to, domain repositories and societies have that disciplinary expertise, and we need to fund them to develop leading practices that can be applied across all curation. I'm excited because we have some examples of this already. We need to extend that. And finally, we need to change the reward system. All the participants are important in doing this. Many societies still reward fellowship, excluding open science practices, just based on whether someone, usually an individual, made some great scientific contributions, ignoring the huge team that has helped them. And so on and so forth. So we need to adjust hiring and tenure and promotion guidance to reinforce, hire people that do these things well. A key is if researchers actually include these values in nomination letters and reviews. That gets, if you're going to review someone or nominate someone, that's really important, and so on. So that was the quick tour through this. Thank you. I'm happy to answer questions. There's my email. And I'm available also. Thank you.